Good morning. Gonna talk a little bit about roots today. Um, so to start with, going to go over just the functions of your roots. Um, Four main things that your roots are going to help you do. They're going to provide anchorage for that plant. It's going to help it stay where it needs to stay. And through that, it's also going to help prevent erosion around that plant. Another reason why your roots are important, they're going to help absorb water and minerals. They're going to act as storage for the plant because they're going to have lots of parenchyma cells for storage. And then they can conduct water and sugars from the root up to the stem. So those are the four main functions of your root. So there's before we get started on the differences between your monocot and dicot, we're going to talk a little bit about your primary root. So you have this little structure called a radicle. This is what grows out, one of the first things that grows outside of the seed and grows down. So once it grows past a certain length, it's then considered to be your primary root. So with your dicots, the kind of root system that your dicots are going to have is called a taproot. That's your first drawing that I've given you there on your diagrams. So you've got your radicle there in the center. I didn't label it, but it's that big circular structure. No, actually, sorry. It would be the that side carrot-looking thing. Sorry, that's the radicle. Circular thing's your seed, and so also known as your primary root at that point, because in dicots it continues to go on, but in your monocots it actually ceases to exist. So it becomes that primary root, and then from that primary root on your taproot system, more roots, also known as lateral roots. And that whole structure with one major root with a primary root and lateral roots coming off of it, that is called a taproot system. On the flip side, in your monocots, you get what's called a fibrous root system. So again, you've got that, you can kind of see it because I've kind of drawn over it, but you have the seed, you have the primary root, but eventually you get other roots coming from the stem. So you get some roots coming off of that primary root, but then eventually that primary root dies. So the roots from the other places, like your stem, are going to form your root system. So that whole structure there is called a fibrous root system. So you don't have a main primary root at that point with a monocot. Okay. Just like with your stem, you had a a shoot apical meristem for your stem. So your root is also going to have a primary meristem, or a meristem that creates the primary meristem, and that's called the root apical meristem. So it does exactly what the shoot apical meristem did, only for your root systems. So this is where all of that cell division occurs. Your root apical meristem will produce the same primary, and the root primary meristems are going to make very similar primary tissues that your primary meristems in your stem made. So they're going to be the exact same here. Your root apical meristem is going to make a protoderm, procambium, and ground meristem. It's going to make a fourth thing called the root cap, which we'll talk about here in just a second. So those are the root cap isn't technically considered a primary meristem. So, all right. Just like your shoot apical meristem, your protoderm is going to make your epidermis. Your procambium is going to make your primary xylem and phloem, and your ground meristem is going to make your cortex and pith. So, okay. Your root cap. Actually, let's look at the drawing first. I think that'll make a little bit more sense if we do that first. Okay. So your root cap there is that middle picture on the left. You've got up above. I've got some root hairs coming out. So whenever I think of root hairs, think of if you've ever seen carrots develop kind of hairs on the outside. Those are root hairs. They're very fine, very thin. So you've got at the very bottom is your root apical meristem. Okay, so that's the area of cell division. Then you've got two different regions. The closer region to the root apical meristem is known as your root of elongation. So the cells are kind of growing. Then you're going to get the region of differentiation and maturation, where they're going to develop into other types of cells. That last thing right here, the root cap, that surrounds your root apical meristem. It's mostly made of parenchyma cells. And the root cap cells, so I've drawn them kind of at the end of the root there. Its function is to provide lubricant so that root can penetrate further or deeper into the soil so your roots can grow. Next to it, I've drawn you a root cap cell, so you've got the cell there, and then all the way around it is the slime or the pectinaceous material that's being produced that allows or makes it easier for the root to grow underground because it's having to move and displace dirt and other tissue, plant matter, anything, basically anything else that's underground. So that pectin, just a side note, does come from your Golgi. So that's kind of what your root apical meristem looks like. So it's going to be further down into the soil because that's where all the growth is going to happen. Okay, time to look at the root anatomy. So both your monocot and your dicot are going to have these 4 parts. They're all going to have an epidermis. Your epidermis can create root hairs that I kind of drew up there, and those are all obviously going to help anchor the plant further. The cortex, they're both going to have the cortex. It's going to be made out of parenchyma cells, so its job is going to be to serve as storage. So that'll be right underneath the epidermis. Then you're going to have 2 layers in the center, and then you'll have your vascular tissue inside of that. You're going to have your endodermis, which is the outer layer. So it's going to surround your vascular tissue, or your primary xylem and phloem. And then the inner layer is the pericycle. So your endodermis those cells are going to secrete suberin. This is going to create kind of a hydrophobic waxy chemical that is going to occur on your transverse and radial walls of your cells. This layer that's going around the transverse and radial walls of your cell is called the Casparian strip. I'm going to come back to that here in just a second. Your pericycle, that's going to be the inside layer, that's going to form your lateral roots. Okay, so we're actually going to skip these bottom pictures, which is your dicot roots, and we're going to flip to the back. Okay, I've drawn you a whole mess of pictures here on the bottom half of the page. So this little box is going to represent an endodermal cell. Okay. So what I mean by that suberin being produced by the transverse and radial walls of the cell is depending on which side of your cell it is. So we've got 6 sides, 3 different names for the sides. Okay? The top part of your cell and the bottom part of your cell are going to be the transverse sides, the top and bottom. Your right and your left sides of your cell, those are called the radial walls. The front and the back of your cell, then, that's facing you, is going to be called your tangential wall. So, I've drawn you two other ones that kind of maybe give you a better understanding. The reason why they're called radial walls and tangential walls, the radial walls, if you were to cut it, your radial walls would be parallel to your radius. And then your tangential walls are going to be perpendicular to your radius. Okay? So, if you look at those three boxes below that, that's showing you kind of the layer of the endodermis. So I've kind of blown it up for you. So the epidermis would be on the top. Your vascular cylinder, your pith would be towards the bottom. This is the suberin that's being produced that makes up your Casparian strip there in the middle. Okay, I gotta push pause. I'll be right back.